Let's get started. Hi, folks. Thanks for joining us again today for our webinar on decentralized identity. This time we're using the Microsoft stack. This is our fourth webinar in this series on decentralized identity. If you missed any of the previous ones, you can catch up on the Condatis YouTube channel. My name is Chris Eckl. I'm the CTO at Condatis, and I'm joined here today by Antonius Tsikrikas, one of our lead developers. So in the previous webinar, we covered some of the standards and protocols being used in decentralized identity. We then looked at the agents and wallets which implement the standards and allow the users to hold, manage, and share their identity. And we looked at the interoperability challenges and had a demo of the Condatis staff passport system to see decentralized identity in real use. In the last session, then, we deep dived into the Hyperledger area stack, and our colleague Mikko led us through some of the demos using the Evenem stack with their Verity servers and the ConnectMe as a wallet. Now, in today's session, we talk more about the Microsoft decentralized stack. I'll be covering the SIOP protocol, and Antonius then will show us a demonstration using the Microsoft Authenticator and the Azure decentralized services in AAD. He will show us how to set up an issuer, how to configure credentials, how to register them in Azure, and also show us then how to configure verifier, how to issue credentials, how to verify credentials, and then we cycle back and use the Condatis SSI or IDC bridge to show how a relying party can use credentials from either stack, the Microsoft stack that we're introducing today, but also the Hyperledger stack, and we'll show it with the ConnectMe app. So before I pass over to Antonius, let me do a quick summary of the SIOP protocol that Microsoft's leveraging. SIOP, or Self-Issued OpenID Provider, is part of the OpenID Connect core specification. It's a part of the specification that allows for personal, self-hosted OpenID providers to issue self-signed ID tokens. In the world of decentralized identity, a wallet is a SIOP, so a self-issued OpenID provider, an identity provider, and it's using OpenID Connect to communicate, to send and receive messages between the agents. Self-issued doesn't mean it self-attests all the information it's going to include in a message, just that it will sign the message and it can be verified with the standard OIDC practices. So the wallet or the SIOP agent signs the token it issues when communicating and sharing verifiable presentation. And just like in Hyperledger's DITCOM, SIOP defines how credentials are issued and how verifiers can ask for proof of a verifiable credential. OpenID is already widely adopted in the development community, and as an authentication mechanism, and therefore, has been thoroughly tested over time. People and developers are already familiar with the flows, the OpenID flows, and the token data exchange when you do OpenID authentication requests. SIOP is just the same as any other OpenID Connect flow. There are just a few new parameters and claims. For example, there's a request parameter within an authentication request that includes a JWT token that describes what is needed to satisfy the request. verifiable presentations are returned within a JWT token again, and it's the verifiable credentials data scheme that's still used in there. By using OpenID Connect SIOP, that allows really easy adaptation of self-sovereign identity, as it's already well trusted and very familiar in the development community. Microsoft has deliberately chosen to use OpenID Connect over the JSON that Hyperledger is using. The other part of the Microsoft stack that's needed in decentralized identity is the registry technology. And Microsoft is calling this the ION network. Microsoft uses SITRI and the identity overlay network, hence ION, to provide a way to locate the decentralized identifier, or DID. And the DID describes where to find the public key of a holder and the destination to find additional information about that DID. The identity overlay network is a public, permissionless, decentralized layer overlay that runs on top of Bitcoin and leverages the SITRI protocol. Now, the SITRI protocol is a blockchain agnostic protocol that was really designed to support global scalability and immutable append-only log with no central provider or authority, and it's censorship and tamper resistant. This acknowledges this is really accomplished by leveraging decentralized ledger technology and supporting a small SITRI, hence the name, that is written back as it's full, as the block of transactions is full, back into the underlying ledger, in this case Bitcoin. And enables scaling as Bitcoin itself is slow and costly for every transaction. So ION's a DID method that uses Bitcoin and SITRI, and the use of the Bitcoin network as a ledger enables a massive scale and cost efficiency and deployment flexibility. And if you want to find out more about the Microsoft Identity Stack and the preview code that we're using here today, please use aka.ms/opendid. Now let's go to the more interesting stuff, the actual demo, and let me set up the demo, what we're trying to achieve today. First, we want to set up an issuer and register and configure the credentials the issuer can issue. Then we want to configure verifier, and then we want to issue credentials and verify credentials via the Authenticator app. And then we want to bring into play also the Condatis SSI OIDC bridge and have a relying party that communicates with the bridge and uses the same credential. But also will then show how a credential on a different stack, like the ConnectMe wallet on Hyperledger stack, can also be used for this relying party. I want to pass you over now to Antonius to start with the first demo.
Thank you, Chris. Hi, everyone. To configure an issuer, we will need to have an Azure Active Directory with premium license and an Azure subscription to create the necessary resources. Also, a free trial is enough. The resources we need are an Azure Key Vault to create the cryptographic keys and an Azure storage account to upload the verifiable credential configuration. Once we have everything in place, we can proceed to configure our Azure Active Directory to use verifiable credentials. We can access the verifiable credentials blade using this link if it's not available in the services list. On this page, we will need to fill in the organization name, the domain URL, and select a key vault. Once we save the settings, Azure Active Directory will create the keys in the key vault and will publish the DID and the public keys to the distributed ledger. The public keys are used to manage signing, recovery, and updates for our DID. Now let's proceed with the configuration of the verifiable credential properties. This can be configured using two simple JSON files, the rules file and the display file. The rules file contains the verifiable credential type, which associates the credentials with the specified schema, the expiration of the credentials in seconds, also the identity provider configuration, which can be any identity provider that supports OpenID Connect, together with the registered client configuration. Here we're using Azure B2C as an identity provider, and please note that the redirect URI must be the same with the one displayed here, as it represents a deep link for the Microsoft Authenticator. Finally, it includes the mapping of the identity token claims to create the credential attributes. The display file contains configuration that defines how the credential card will look in the Microsoft Authenticator wallet. Here we have selected the card to appear with a relatively dark background with white letters and the Condatis logo. Also, we specify the messages that Microsoft Authenticator will show to the user, and information about how the credential attributes will be displayed. Once we have both files ready, we can upload them to a blob container in the storage account and proceed with the credential configuration on the Azure portal. To create a credential in the Verifiable Credentials blade, we can select to create a credential, or at the upper left side, we can select to add a credential. In this form, we fill in a credential name, we choose the subscription on which the storage account exists, and we select the configuration files that we previously uploaded. After a successful validation of the configuration, the credential is created and the credential contract is generated. This is another JSON file that combines information from the two configuration files. Now let's move on to configure a Node.js app. For the purposes of this demo, we have created a single app, both for issuance and verification of credentials. The app is using the Microsoft Verifiable Credentials SDK to generate the issue and presentation requests, and the Azure Identity SDK to communicate and authenticate to Azure Key Vault. This application is also registered on Azure and has granted permissions to perform operations on the Azure Key Vault. Now let's see how we configure it. First, we import the necessary packages to interact with the Key Vault and to generate or validate the SIOP requests. We also need to specify the credential type which we used in our rules configuration file, the credential contract which was generated when we created the credential, the issuer DID, and a configuration file that contains the information about the app registration and the key names. Finally, we use the Azure Identity SDK to generate the cryptographic keys in the Azure Key Vault, and that will provide us with a crypto builder object that will be used later to sign the SIOP requests. The issuer is creating a requestor builder to generate the request object of a SIOP request for credential issuance. We specify the credential type in the schema property and the credential contract in the manifest. The request object is in JSON Web Token format, and here you can see a decoded sample. During the credential issuance, Microsoft Authenticator will receive this object and will use the credential contract to get the identity provider and other information. It will then use this provider for the user login to retrieve the information that will construct the credentials. Similarly, the verifier is creating a requestor builder to generate the request object of a SIOP request for credential verification. The request object is again a JSON Web Token, and here we can see the decoded sample. We specify only the credential type in the schema property, and we also include information about the verifier that will be used by Microsoft Authenticator. These are the client's name, the logo URI, the terms of service URI, and the client ID and redirect URI for the Microsoft Authenticator to return the presentation response. Once the verifier receives the presentation response, it creates a validator builder to validate it. It validates the presenter and the signature of the presentation response, and also the signature of the presenter and the issuer by looking up the keys on the ledger. The validation result contains the verifiable credentials, a sample of which you can see here. Now, before we proceed with the demonstration of the credential issuance, I will pass on to Chris to give us some details about the issuance flow.
Thanks, Antonius. So now that we have all the setup in the system, let's look at what happens when we issue a credential. So we have the setup, we have Azure Active Directory Premium configured for an issuer, we have the credentials configured, we have an issuer, a Node.js app, and we have a B2C that is acting as a credential provider. Let's step through the step that's happening while issuing. So I've tried to sequence diagram the steps so it's clear for everybody. The user comes along to the JS app, which is part of this body of items that make up the issuer. So the Node.js app gets a request and generates a QR code that is used to make a connection between the Authenticator app on the mobile device and the Node.js app. So the Authenticator scans the QR code, and by doing that, has a reference to the issue request and retrieves the request and gets a response of the issue request. So it now knows what the app wants to issue and where to get it from. It needs to then resolve the DID document that describes and the credential contract that describes what is part in that credential and how to find it. So it resolves both of them from Azure, and then will show an add card screen within the Authenticator, and the user can select that screen. From that screen, the user is redirected to the place where they can get the claims for going into the credential. So that could be any OpenID provider, any identity provider, any other claims provider. In this case, we've set up B2C to do that. So steps 5 to 22 is a normal OIDC flow. The user gets redirected to an identity provider. The user authenticates, and then at the end, with code flow here, gets an identity token with the claims that should be embedded in that card. The authenticator then displays to the user those claims and say to accept those claims as a verifiable credential in the card, and the user accepts it. And when the user accepts it, as an Azure service are used within the issuer that converts this ID token with the data to a verifiable credentials data model within a JWT that the Authenticator app then stores within its storage and uses later when it needs to share those details. So that's the theory. Let's look at it, how it looks like when Antonius shows us. Antonius, over to you.
Thank you, Chris. Let's begin with our sample Node.js app to issue our credentials to the Microsoft Authenticator wallet. As we said previously, the app will use a requester builder to generate a SIOP request, and this request is included in a QR code that will be read by Microsoft Authenticator. Let me use Authenticator to scan this QR code. Now, Microsoft Authenticator is using the SIOP request to retrieve the request object from the Node.js app. It will then read the configuration from the credential contract, and as you can see, the card styling matches the one we specified in the display configuration file. Let's continue with logging in to the identity provider. After a successful login, the authenticator receives the identity token with all the information. Let's add the card. And now the authenticator is sending a SIOP request to the Verifiable Credential service on our Azure AD to generate the verifiable credentials. Once the operation is complete, we can see the card added to our wallet. And if I tap to open the card, we will be able to see under the card details the attributes of the credential that we have been issued. That completes the issuance flow. And before I continue with the verification flow, let me pass back to Chris to give us some details for that flow.
Thanks, Antonius. It's so much easier to see the flow in action rather than to only see the theory. But I'll go back to the theory for a second. So we have the setup of the verifier. Again, it's registered in AAD, in Azure Services, as a verifier to this credential. And we'll step through the steps needed to do the verifying of the credential. So this time a bit similar to the issuing flow, but we first need to have this understanding between the authenticator and the Node.js app. So we set up this communication with a QR code. We create a request for a presentation and present the QR code to the authenticator, and the authenticator scans the QR code and can therefore have a URL that goes back to the Node.js app that gives the presentation request back. Once the authenticator has the presentation request, it can then resolve the information in the request by querying the DID information via DID resolver and get the discovery of what's there. You can then ask the user, are you happy to share that information with this verifier? And the user will say yes. And when the user says yes, the Authenticator app shares those verifiable credentials it has in storage via the Azure services as a JWT to the Node.js app. And the Node.js app then can validate the JWT, standard validation. As I said, OpenID Connect is really easy. And then within that token are the verifiable credentials as part of the claims. So very simply, the verifier can then do whatever it wanted to do to present protected resources or do whatever business flows needed afterwards to go on from there. Now, to the fun part again, we'll see a demo of this verification. Back to you, Antonius.
Thanks again, Chris. We can continue now with the verification flow. Similar with the issuance flow, the app will use a requester builder to generate a SIOP request, and this request is included again in a QR code that will be read by Microsoft Authenticator. Let's scan this QR code to verify our credentials. Similarly with the issuance flow, Microsoft Authenticator is using the SIOP request to retrieve the request object from the Node.js app. It will then read the configuration from the request object, and it will display the presentation request. If I tap on the card, we will see the attributes requested by the verifier. Now I will tap Allow to share these attributes. And now the authenticator is sending again a SIOP request to the Verifiable Credential service on our Azure AD to generate the presentation response. Okay. Sorry about that. Maybe we'll need to try that again. Let me scan again the QR code and allow the request. And now As you can see, we have successfully verified our credentials on the verifier. Here we have all the attributes of the credentials we shared, and that completes the verification flow. Now I will pass back to Chris to give us some details on how we can verify credentials for multiple wallets using the Condatis SSI stack.
Thanks, Antonius. Live demonstration are always exciting. You mastered well. You see how easy it is using the Verifiable credential. It's just scanning. For the user, it comes up allow, and you click allow, and it's shared. If it works first time, but sometimes you need to hit twice. So what? Yes, coming back to the Condatis SSI stack, as you might remember from one of our previous seminars, what we're trying to do is abstract from the relying party, the actual underlying technology a bit. So what we allow the relying parties, the verifiers, is to give free choice to the user what wallet the user wants to use. So it doesn't matter whether the user has data in the Microsoft Authenticator wallet, or for an example, the ConnectMe wallet from Evernym. For the relying party, they can consume data from both wallets, and we think the decision is up to the user to choose the right wallet for their need. So we have a small demo that shows this relying party getting data from both of the credentials we set up previously. So that's back to Antonius for the last demo of today.
Thank you, Chris. Here we have a sample app that uses OpenID Connect to communicate with a bridge. This app is used only for demo purposes, and the only reason we have the client ID and the secret in this form is to test different clients on the bridge. I'm using a scope that, according to the client configuration, is supported by both wallets. So let me submit this form to proceed. The bridge is reading the client configuration and is returning us the wallet options. Let's start with Microsoft Authenticator. We've got the QR code with a SIOP request. I will scan the QR code. And I will tap allow to share the attributes. And as previously, the Authenticator app is sending a SIOP request to the Verifiable Credential service on our Azure AD to generate the presentation response. Now we're back on the sample app, which has received the token from the bridge that contains the requested attributes from the Authenticator wallet. Let me switch wallets. And let's move on to send the same request to the bridge. This time I'm going to select Evernym's ConnectMe wallet. The bridge is communicating with the agent to generate a QR code that will connect the wallet with the agent. I will scan this QR code. I got a notification that the connection with this wallet already exists, and now I should receive a new message that will contain the proof request from the agent. I will share these attributes. And we're back again on the sample app, which has received a token from the bridge that contains the requested attributes from the ConnectMe wallet this time. That completes the demonstrations for today. Let's go back to Chris to see if we have any questions.
Thanks, Antonius. So great demos, because it showed really what's doable with the system and how easy data sharing is. Let's just see. One of the questions is, we didn't see all attributes in both of the flows with ConnectMe and with Authenticator. Antonius, could you just explain why we didn't see all the attributes in the credential?
Yes, for the purposes of the demo, since the two credentials are different, we are just requesting only a subset of the attributes that are common for both credentials.
Okay. And one of the question is that Microsoft code available for all? I guess we can answer that. The Microsoft is in private preview. You might have seen a few videos on the Microsoft site around it. They are planning to put it in public preview very soon. The URLs you saw are freely available and you can use it, but be aware you can't use it publicly yet. And I think that leads on to the question around the Condatis stack. That Condatis stack and the bridge we are showing is actually available already. It's in use. However, it's not in use as Antonio showed it with the Microsoft button and the Connect Me button, because currently for production release, we can only use the Connect Me stack. So you will only get Connect Me, but if you use the Condatis bridge, you're future-proofing yourself for the other options. Just see what other questions there are. The Connect Me app had this connection in there. You first had to accept a connection and then release the data. And the Authenticate app, you just scanned. It didn't seem to have the connection, and that's a particular feature of the OpenID Connect protocol, because it's just a responding protocol. There isn't a connection setup needed. In Hyperledger, we have this concept of bits that have a secure connection between agents, and that connection can survive a transaction. So an issuer that has a connection to wallet could at a later stage issue new information or do in Hyperledger, we heard from Mikko, we have this question response protocol. Well, that's not possible if you don't have a connection. So there's times where it's good to have a connection to communicate with your customer, but other times when you're a customer and you just share a bit of information, why do you want the verifier to keep your connection around? So if I have a border crossing, it's really I'm proving that I can enter the country, but why should that border agent keep a connection with me for a longer time? I think, yeah, the Microsoft Authenticator app, this Credential is only currently available on the Android version of the app. It is in the iOS app, but it doesn't fulfill all the features, so we couldn't show it on iOS today. That's all the questions of today, I think. Okay. Let's move on then. Just so a summary, what we saw today is we saw the summary of the SIOP protocol and what it does and what the Microsoft stack is consisting of. And then we saw a demo of setting up an issue on the stack, configuring credentials, setting up the demo app and the verifier, issuing credentials, verifying credential, and then we saw interoperability. I think a very important point, the ability to speak to two different wallet stacks using the Condatis SSI or ODC bridge. In the next decentralized identity webinar, we'll look at the benefits and use cases. So that's really a great opportunity to translate this techie stuff into actual business problems. That'll be in February, so please join us again then. If you've also been following the Condatis B2C webinars, the next one is in February also, and that's around advanced features of B2C. If you've missed any of the webinars, they are all available on the Condatis YouTube channels. You can also hit subscribe there, and then you get notifications when we publish next webinar. If you're interested in the decentralized identity stack and the Condatis solution as well there, or want Condatis to help you with exploring decentralized identity, drop us a line on info@condatis.com. We'll help you any way we can. Thanks again for joining today, giving up your time. Thank you and goodbye.